today is for you guys. The session is really to inform everybody on this call about how to maximize your return on investment in ArcGIS and how to get the most out of the system. Most, if not all, the capabilities you'll see here today, you already have access to. But I would personally encourage you as we move through today's session to think about two things. The first being to keep an eye out for something you can learn today and apply to your organization immediately. The second thing then is how ArcGIS could now start increasing your return on investment in the system. So after what you see today, could the system contribute more to revenue growth? If information and access to it impacts your revenue, how can ArcGIS get information into the hands of those who need it? Could the system reduce costs for you, right? So from what we show today, is it possible to automate a process or restructure it to take advantage of the data organization and analysis in ArcGIS? Could the system also help in cost avoidance, right? Just because a task has always been done a certain way doesn't mean that has to continue. Is there a better way to carry out some tasks in ArcGIS? And perhaps the biggest ROI or return on investment question we see in Ireland is that ArcGIS can save a lot of time. So is there something you see today that has you thinking, how much faster can a process be carried out with ArcGIS? So those are just some of the questions you get answers to today. And speaking of questions, if you do want to ask the team any questions at all throughout the session, we have an online form that I'll paste into the chat shortly. It'll take you to a Survey123 form where you can ask as many questions as you like. What I would say is do not hold back. If you do have a burning question, now is a good time to ask it. We'll have an interactive Q&A with everybody at the end. It is a Survey123 form, right? Which I'm sure you're all pretty familiar with at this stage. I thought if I used any other software, I'd probably get my marching orders during this call. So I hear good things about Survey123 for data capture. So I figure give it a shot today, and we'll see what happens. And look, I mentioned earlier that today is really only one aspect of our commitment to you, our customers. And just what I mean by that is that we are 100% invested in rolling these types of sessions out at least once a quarter throughout the next few years, right? And its main aim is to keep you all well informed as a group, answer any of your questions, and also take on board any feedback you have for us. We're delighted today to be joined by our colleagues over in Esri Inc. from the Telco and Utilities team, a team specifically set up to cater for this industry's specific needs and how they can be met with ArcGIS. It's worth noting that we at Esri Ireland, we're powered by a much bigger global network of product, industry, and solution teams, right? In Ireland, we're 61 people, 50 of which sit in professional services, and their sole job is to work with customers like you to deliver projects and configure ArcGIS as a system. So it's never just one person helping out our telco customers. We have Dermot, our head of sales, Eamon, our CTO, myself and Phil as account managers, Rob, our principal consultant, Phil, our senior solution architect, as well as many, many other consultants. And the great thing for you guys, all on the call today, is that we are here to help any way we can. I do appreciate that sentiment gets thrown around a lot by other companies. So to put my money where my mouth is, I've put our email addresses here. I'm sure a lot of people on this call already have our direct mobile numbers because we work with you quite closely. But if you don't, here is the customer success team in Esri Ireland. And we are genuinely, I cannot stress this enough, we are genuinely all here to help. If you need anything, just reach out to one of us, okay? I've put the friendliest people on the bottom row. I'm kidding, of course. All 6 of us, all 61 of us, in fact, are here to help, and we're happy to do so. So speaking of people who are here to help, I'm going to pass you now to Patrick and Mark from Esri Inc. They'll introduce themselves, but I do think everyone here is going to get a lot of value out of what they have to say and show today. So once again, thank you all for dialing in, and over to you, Patrick and Mark.
All right, thank you, Adam. Really appreciate the opportunity to spend more time with you all and today, and really appreciate the time that you're taking out of your schedule. Usually at Esri, we really like to have these kinds of meetings in person or have them one-on-one. And, as we all know, that's just not going to happen anytime soon. But we hope for the day that we can spend more time face-to-face and collaborating together. So over the next, 40 to 50 minutes, myself and my colleague Patrick will be sharing with you, really our vision at Esri for what a comprehensive geospatial system for telecommunications organizations is and will be. So next slide, Patrick. A little bit more about ourselves. I'm Mark Robbins. I'm the international team lead for our utilities, telecom, and water utilities sector here at Esri. We're a dedicated group, as Adam had mentioned in the introduction, within the Esri organization, where our staff only work within infrastructure, and we don't get involved with other projects. We're dedicated to the industry, and we were a team of probably close to 60, 65 individuals, from technical advisors to solution engineers to planners and other types of business development staff. So it's utilities, telco, and water, and that's all we do. So with me today is Patrick Huls, who's a solution engineer, a senior solution engineer on our team that works exclusively with the telecom industry and has a great amount of experience and has a great story to share with everybody. Next slide. So just a really high level agenda, how we see things kind of flowing out during our time together on the call. It's really straightforward. First, we wanted to start off by sharing, what we see is happening within the global industry, what the trends are, and in the telecom market, and how that relates to GIS and into ArcGIS in particular, which then leads us to how ArcGIS supports telecom organizations' workflows. And we'll share a few user stories or case studies with you as well, just to give you some real world examples. And then finally share with you, where we see Esri and our technology going over the next few years, or really the next few months, that are specifically of interest to our other telecom customers and users around the world. So with that brief introduction, I would like to turn things over to Patrick here for a little bit and let him share his story. Thanks, Patrick.
Yeah, thanks, Mark. So I'll stay on camera for this first slide, and then I'll drop camera as we get in this to help save bandwidth. But very happy to be here with you all and share some of the insight that we have in the industry and where we really see geospatial technology going. And so we wanted to start by talking a little bit about some of the trends and the challenges that we're all experiencing. I think one that comes to mind, even maybe above and beyond things like 5G, is just responding to COVID. For example, I'm not in my office. I am home. My hair has gotten quite long in quarantine, but this is an adjustment we've all had to make. And I think service providers have also had to make an adjustment and really see how their infrastructure could respond to folks working remotely, moving home. How is the network going to handle this? And I would say for the most part, the communication networks have held up, right? They've been very resilient to this increase in bandwidth in remote areas. But where we've seen kind of a trend or a need to evolve is how internal systems are being delivered to the service providers' employees. No longer are workers now sitting behind a desktop in the office on internal networks. So VPN into these systems, remote work out in the field, there's all sorts of challenges and hurdles. And so I think we've seen a big evolution in this digital transformation shift to allow for more cloud-based systems, more remote work, And hopefully, as we see here today, the Esri technology and ArcGIS as a geospatial system can really help support a lot of those initiatives. So I'm going to just drop video, and then we'll move right along here. A couple of other kind of trends that we've seen globally, really to meet the needs of 5G rollout and really just more broadband consumption, are things like government funding and regulations, and having these government subsidies for broadband expansion to rural parts of the country. I'm located in the U.S. We have very similar programs as in Ireland, where the government is providing funding for this rural broadband expansion. So along with that, and the need to fiber feed and backfeed new small cells for 5G, there's just a lot of infrastructure build out happening right now, mainly fiber build out to support wireless technologies and this broadband expansion. And so what we have at Esri have seen is really this need for more of this, what we call next-gen network management. Because of all of this broadband expansion and the need to move so quickly, as well as work with all of these contractors, design firms, construction firms to make sure that we're building out this broadband as quickly as possible, the legacy ways of having these siloed systems that were specialized apps to do designs, maybe not as easy to get that information into the field, requiring a lot of exporting and transitioning of data from the system into a PDF or a KML, KMZ for Google Earth. It's just not a very efficient way. So what we've seen is this need to have a complete geospatial system that not only can allow you to manage networks, whether they be wireless, fiber, copper, coax, hybrid, outside plant or inside plant, manage all of those networks in one system, but have the tools that can work and design against all of these different types of networks. So this allows organizations to make that smartest decision possible as far as, if we're building out broadband, do we build fiber to the home? Do we do something like fixed wireless because it's more cost effective for that last mile? Those are geospatial questions, and having this information in a authoritative system of record with the tools that all work with that data is really that evolution of GIS and geospatial and telecommunications to support this next-gen network management. So what we wanted to do here is start off by really showing now what we mean here at Esri about kind of next-gen network management and what that really looks like. And so next-gen network management really starts with that comprehensive geospatial system that not only allows you to have the latest and greatest geospatial tools, but access to different base map layers and authoritative geospatial content through web services right at your fingertips. It also allows you to not only map your facilities and outside plant in a 2D environment, but also enables 3D mapping as well, and allows you to model those physical networks as close to reality as possible. And so what we've seen is these planning teams and operations teams, not only do they want to be able to manage and model their fixed line assets, but they want to integrate their wireless assets, their coverage maps into that one authoritative system. They also want the ability to model the different network tiers and levels of their network, from submarine through regional fiber rings all the way down into the distribution or feeder networks, and then right in through those access networks. But being able to visualize all of your physical networks in one location is definitely one part of kind of this next gen network management. But being able to model your assets almost as digital twins is also very important going forward. So just like this cell site that we see here, we're able to model within 3D the actual measurements and pieces of equipment on structures like this cell site, and get information that is stored within the GIS about these towers and antenna. So this isn't just a pretty picture, but all this information is being stored in that authoritative spatial database. And so now we can click on each element on our tower and pull up that information. An interesting story here, these towers that we're seeing here were actually provided to us by Cellnex in Spain. So working with our Esri Spain distributor, they provided us these Revit files that we could integrate in. Now, modeling these towers as digital twins is definitely one aspect of this. But being able to manage and model the connectivity of your network is also very important in next-gen network management. So for example, let's say I wanted to understand how we are serving this particular tower through this microwave receiver. So I want to understand the relationships and connectivity of our network all the way through the wireless microwave signal back through our fiber network. So I selected our microwave receiver, and I want to run an upstream network trace to see how we are connecting this particular tower. So we'll go ahead and run this trace here. And then as this trace is running, it is selecting that microwave receiver and then looking at the upstream pieces of equipment that are connecting that tower. So on the map, we can see a few assets that have been selected. But we can also go to our selection tree view, which then provides us with more information on all the pieces of equipment that have been selected based on that trace. So let's zoom in to the upstream tower that is serving that site. We can see the antenna on this particular site that has been selected and highlighted. And as we pan out, we'll start to see the fiber backhaul that is feeding this particular tower. And so now we can follow the highlighted path here all the way back to our central office or our head end, or we can go to our selection tree view and we can just select our central office and then zoom right to there. So next-gen network management is not just about having that ability to model your physical networks as digital twins and the connectivity of your outside plant world, but it's also moving into the inside plant world in one complete comprehensive geospatial system. So here's our central office and our data center. And within that same geospatial system, we can also model the floor plans of our central offices and data centers. So we can easily then see floor by floor those floor plans. And now on the second floor here, the main data hall, we have a rack that has been selected. So that upstream network trace has gone right into the data center, and we're able to see the exact rack and then the switch that that fiber trace has terminated at. Now, inside plant management is not just about having that ability to model your floor plans and understand space availability, but it's having that ability to understand rack space availability and what pieces of equipment and patch panels are on different racks. And so what we can do is, based on that trace result, we can then apply our selection to these interactive diagrams that then give us more insight into the exact ports that those fiber strands are actually terminating at on this rack. We can also see that originating switch for those towers downstream. Now, these rack views are also two-way interactive. So, for example, we can select our network switch here, and then I'll apply this back to our map. And then from here, what we can do is perform a downstream network trace to select all the cables and strands being served out of this rack location. So we'll select our switch, and then I'll add that as a starting point for our trace, and it'll be the outbound ports. And then we'll perform a downstream trace here. And so what this trace will then do is, again, select those cables and those strands that are being served out of this central office, and more importantly, coming from this particular rack and switch. Now, once we have that, we can start to do different types of reports on those trace results. So, for example, we've got this dark fiber strand report here. So this chart shows me all the strands that are within our network. And we can see what strands are available and which ones are in use. But we can then filter that selection, or we can filter that chart based on that trace selection. So all the strands being served out of this rack, we now can see how many are available, which ones are in use, or which ones are pending customer connections or are reserved. So what does next-gen network management really mean? It's being able to manage and model your physical networks, no matter the network technology, in one authoritative system of record, both your outside plant and inside plant, using this comprehensive geospatial system. So let's transition now and talk a little bit more about how we were able to do that demonstration, but more importantly, how ArcGIS and the technology can enable your organization to start to be able to model your networks more efficiently and get this information into the hands of users and field personnel who need to access this data as well. And so we do this with our comprehensive geospatial system called ArcGIS. Most of you on the call are probably familiar with ArcGIS, but it really provides mapping, analysis, and data management throughout the whole organization and enables collaboration. It's secure and services-based. So based on your user role and identity, it enables access to different views of the network or views of designs and plans. And it really encompasses kind of three major systems. A system of record, so that's your enterprise data management. That is your authoritative data source for your physical networks and for other geospatial data. It offers a system of engagement that allows you to then publish and share these secure web services of those authoritative data sources to members of your own organization as well as externally. And I'll talk a little bit more about that here in a minute. And then it offers a system of insight. So hundreds of different analytical tools that can allow you to do strategic planning. So looking at capacity, looking at call records and being able to analyze big data spatially to look at where you need to put small cells or backfill with additional fiber, as well as route optimization, and we'll see a little bit of that in an upcoming demonstration. And then what we've seen of late is this notion of system of engagements or systems of systems, being able to integrate the front end portal that allows for the access to these maps and apps and layers, and integrate those with other geospatial portals. This has been great for contractor collaboration. So a service provider or carrier can deliver requirements for a design through a service to a contractor that can then design directly on top of that map or do a high level design and submit that through that web service back to the carrier, and then allow for the approval process to take place without exporting of data. Now, built on top of ArcGIS are a suite of solutions for telecommunications. And if we had all day to spend with you all and start to get into the happy hour, we could go through all of these. But today we'll focus just on a few of these solutions and really highlight them in the upcoming demonstrations. But one comment I'll make is that these solutions are very configurable and allow you to take that geospatial system that you've invested in and leverage it across the whole ecosystem and life cycle of the network and the customer journey. So from planning and understanding where you need new network and doing things like market analysis, through building out and planning and designing the network and constructing it, to actually selling the services and ensuring that your networks and service stay up and running. And one of those key solutions that powers a lot of this is the communications data management solution. These are fairly new solutions that really provide that asset management and data management capability for communication networks. And we've got kind of two flavors of this solution available for our users. So the first solution that I'll call attention to on the left is this communications data management for ArcGIS Online. So this is a very easy to deploy solution, and I'll show this later. 2 clicks and it stands up maps, apps, layers, and a database for you to start doing basic asset management. So for things like high-level design, instead of using Google Earth and exporting KML, KMZ, if you want to start doing those high-level designs in web services and get those web services to contractors, this is a great starting place. Sets up a schema that you can modify, allows you to then take that information easily out into the field to do walkout surveys. Then on the right-hand side, we've got the communications data management for ArcGIS Enterprise, which takes that same kind of data model for managing wireless or fiber or coax and copper, and expands on that to a greater level of detail, allowing for all that connectivity and strand and port management that we saw in that original demonstration. So being able to do tracing on the network and have that true network management system. So whether you are just getting started or looking to deploy something to do some high-level designs, or you want to start leveraging a more robust system, complete engineering and design, there's multiple flavors to get you going that can then light up the rest of that wheel, as we'll see here.
I think that's a really good slide, Patrick, because I think the customers on the call, you know, a lot of people are in the left-hand box on that, and some have dipped a toe in the right-hand box. But it's great to know that, there's different horses for courses in terms of how we platform a system for our customers, and also that there's headroom for them to grow, possibly from one to the other, or into a hybrid mode where they're actually using both, one for the sort of the design and the walkout stuff and the field mobility, and the other for the actual enterprise network management and operations side of things.
Yeah, great comments and good points. And the nice thing about this geospatial system and the architecture behind it is it's services based. So the front end clients and applications, some that we'll see here in a minute, can consume services whether you are leveraging more of that basic asset management, simple points and lines to start storing network information or design information, or whether you're using a more robust modeling down to the strand and port level. The applications on top can leverage the services from both, either standalone or in a hybrid situation, just as you mentioned. And we'll actually see that in some of the upcoming demonstrations where we are doing a hybrid of both, using the online solution to do SketchUp's high-level design so we can engage more easily with our contractors, but then consuming those services and data and leveraging the more robust system to do a detailed design and engineering. So the first kind of solution and demonstration that we wanted solution we wanted to demonstrate here is really a desktop and walkout survey solution. And what we've seen is that there's just so much design work going on and build out of networks that this has been very powerful in really just almost eliminating kind of that Google Earth paradigm, where there's a lot of export of KML, KMZ. I need imagery, I need 3D. I want to do remote desktop surveys without sending somebody out into the field numerous times. And so the ability to stand up these integrated services and mapping has definitely helped in these desktop and walkout surveys. So now let's jump into a demonstration here and really highlight some of these apps and solutions in action. So for this desktop survey, I'll highlight kind of a B2B situation where a business has requested service and we want to essentially extend out some network and provide a drop to them. Kind of a very lightweight design effort, but it'll really highlight a lot of the capabilities. So on our map here, we've got a lot of network with red behind it, which is really just stating that it's kind of in a planning phase, it's not as built. But we've got a customer here that has called in requesting some service from our organization. And so right now we need to understand what it's going to take to provide them with fiber and our business services. So we could sketch up a route in directly on this application, but first we may want to look at optimizing this route. And so using some of those analysis tools within ArcGIS, we can say, okay, let's look at nearby network access points. In this case, we've selected kind of a distribution hub as our access point. And running the analysis then returns what the cable length is. We can see the path. And then we also can see other businesses along this network path. And then those businesses are listed here and summarized in the upper right-hand corner. So now as we're planning our routes, we can see what a potential ROI would be by selling other business services if we're going to have to build out additional capacity or extend our network to this customer. And then we've also got the ability to add different business rules in here. So for example, if we want to not just look for the shortest path back to our network, but maximize that ROI, and really try and see how many businesses we could pass, we can then run these different business rule logic on top of these planning tools to now get a result here that's quite a bit longer, but the number of businesses passed was, I think, 27, and now it's 111. Now as kind of a desktop engineer, I know that there are some access cable components or some splice enclosures nearby. And so again, all of this network information is available to those desktop engineers to be able to understand where nearest access points are, what capacity is available, and things like that. So here's kind of the shortest route. We've got an access point kind of nearby, and we'll just use this as our example for today. So now that we've got this route, we want to just start to sketch up and add in our fiber drop here that we'll take out into the field to be able to do kind of a walkout survey. So I'm just going to, roughly sketch in what that proposed route is going to look like here, all the way down to the customer, and then we'll add in that route. We can type in an asset ID, the lifecycle status. This is a proposed route. We haven't gotten to the design stage yet. This will be a one strand count, one buffer tube, and we'll just go ahead and save that. So just that quickly here, we've got a route that we now don't need to export and send off to somebody. This is stored in that services architecture that we can take out into the field or pass along through a secure service to a contractor. And so the next stage here is just doing a walkout survey. We want to make sure that there is potential poles that are available. And if not, maybe we have to do some trenching or some direct bury. Now, before we do that, we can also integrate with different street view applications to do more of that remote engineering. Now, this is just a dev version here of this Google widget. We don't want to pay for their licensing. But here we can see, we've got the integrated street view that we can integrate directly in and start to understand what poles and assets may be available for us to attach our equipment to. But we've also got Esri partners that also offer street view applications. So one of them here is this organization called Mapillary that actually allows for crowdsourced street view. So as your technicians are out in the field, as your trucks are rolling, you can collect these images and they will stitch them together and actually create kind of a 360 street view image for you. We've also got another partner that offers the ability to measure directly on top of this street view based on their capture of these images and the LiDAR capture that they acquire when they go ahead and collect these street view images. So there's lots of options to integrate kind of this remote engineering concept into the ArcGIS tools. But we'll go ahead and now just jump right into more of the walkout survey here for this particular design. So I pulled up my tablet and I'm going to open up an ArcGIS app. Right away, we'll notice that I'm logged into the system, but this is not me. This is a field technician persona. So they've got access just to the maps that they need to be able to go out and collect the data that they have to collect. And we'll open up our communications asset collector map, which very similar to the web here. It provides me with access to all of that physical network inventory, while I'm out in the field. I can search for, a design. I can see here that route that we just created in the back office. And then we can go ahead and start to perform a walkout and collect information. So let's say we're going out, we see some poles, and maybe we just want to collect a few different poles here that we see. So I'm going to drop a pole right here, update the location. You know, if we wanted to put in, again, an asset ID, all this is configurable based on the information you would like to collect. And this is, again, kind of proposed to let our engineers know that there's structures available here. We've got some smart form capabilities where we can, add drop-down menus. We can, ensure that the data quality is good as it gets into the system before it gets into the system. And we can take photos and attach photos if we would like. So I'm just going to go ahead and submit that record. Nice thing about this application is I can also then copy that existing record. So I'll just copy that. Same asset ID is fine. And then we'll go ahead and submit that. And I'm just going to drop just a couple more polls in here. We'll copy that original poll again. Same asset details. And then I notice one more poll just so happens to be right in front of the customer, and we'll submit that. So being able to sketch up, modify routes, add additional assets, or even do just some basic map note taking, right? So let's just say we wanted to add a general map node on here as well. So I'm just going to draw kind of a polygon around our proposed design. And it's a general note, it's a medium, and I'm just going to say, ready for design. And add a point, and we'll submit this. All right, so now we've collected some information out in the field that can help our design team be able to engineer this route. And so if we just quickly go back to the office, we'll see through this web app that we've got that same information here that was just collected in the field, and we can see who collected it and when they collected it, and be able to access this information in pretty much real time. Now, this set of apps was actually using that online solution and those online services. But now what we want to do is show how we can then leverage that solution and the data collected for that desktop and walkout survey to do more of kind of a traditional network engineering workflow. I'm just going to take a sip of coffee here before we do so. And then let's jump right into our next demonstration to really highlight more of the network engineering aspect. Okay, so for this, we're going to jump back into the desktop application here, ArcGIS Pro. And we've got another map within this Pro project that allows us to do more of the kind of detailed design and tracing of our as-built network. So if we just pan on over, we can see here the map note that's come in. We also see that kind of high-level design route that is also available for us to start to be able to leverage as our proposed route for our design. So I'm going to go ahead and just turn off our map notes there, and then this layer. And now we can go in and really start to perform our detailed design. So I'm going to start by adding those poles and our structures along the way. pole. There we go. So this first one is going to be a pole with a riser. So I know that we've got some underground network here, and we're going to do kind of a direct bury trench here. So I'm going to add just our pole, initial pole with a riser there. And I want to add just one more pole kind of down here, right in front of the customer. So we'll add that additional pole. Now, you know, within the desktop app, we also have the ability to do different types of kind of productivity tools while we edit. For example, we may want to drop in some spans and poles at the same time. So I'm going to select our pole and span feature here, and we'll just start to edit that as well. Scroll back up. So I'm going to start our span network at the first pole, and then now each vertice that I click on the map is going to drop a pole. So we'll drop a pole there, we'll drop a pole there, and then we'll finish down here. So now that'll add our span network between the poles, and it'll add those additional poles at those vertexes or vertices. And we can see the poles here. So we've got our structure network in place. Maybe I do want to model and manage that we've got a trench here. So we'll go from our handhole here, and we'll just drop in a trench. And now we've got that. Let's add in our telecom equipment. So I know that at the end of this, we're going to need an interface unit with the customer. So I'll drop that asset down. And then we'll just start to add in our fiber cable to this customer. Now, through the design criteria and the business rules of ArcGIS, you can also set up requirements so that users have to enter in information. For example, I can't save this unless I enter in that how many strands and buffers this cable is going to include. So then we'll just we'll start at our access point there, and I'm just going to drop in our drop cable. And you'll notice that we get an error message here. So what is that telling me is that the cable must start at a cable terminator, splice, or splitter. So this is actually a one of those business rules in action. I didn't mean to do this, but it's great that it actually came up to reinforce that. So you'll notice when I hover, I did not start my drop cable at our access terminator here, or a splice enclosure, or a splitter. And so that's really what that error message was saying, that I needed to snap that. And so that snapping is all based, again, on those business rules that you set up. And so as this edit is performing, what it's doing is, one, it's validating that the edit makes sense, which we saw I got an error the first time. But it's also creating the strand features, and it is associating the cable to the structure network. So what we'll be able to see here in a minute is that the span network, the trench, is all associated to that fiber cable. So if we go to our selection tree, we've got our selected drop cable here. And then we expand kind of the relationships and the connectivity and containment of this fiber. And now we can see that this contains one fiber strand that's being stored in our database. And we can see here that there are kind of 3 segments of aerial span that this fiber cable also crosses over, and then the 2 trenches. So automatically we're creating these associations. So as you do tracing and reporting, you can see how many poles a segment of cable is attached to and things like that. So I'm going to go ahead and save my edits here. And then, I may want to also validate network topology. But before I do that, the last thing that I need to do is connect up our strand to the existing network. Now, as I do this, one note and comment that I'll make here is that this release of the solution provides the core data model and the tools that we see here. And through our partner solutions and additional solutions that'll be released, there'll be additional productivity tools to help with these connections that can be made. For example, we've got a splicing tool coming to allow you to have splice diagrams and make these connections through that tool versus doing it through the GIS interface that we see here. But the important thing to highlight is the actual connectivity, and that we are storing and managing all of these connection points within the system of record. So what I want to do is select the connection point for a fiber strand that is available within this access point. And I'm going to load that into our tool here to allow us then to connect that up. Then we'll select our fiber cable, and I'll kind of do the same thing. We'll go and we'll expand our fiber cable. Here is that strand, and we've got this connection point here. And so these are really the connection points kind of behind the scenes that we are connecting together to allow for that splicing to take place between the new cable and strand and an existing strand in the cable. So we'll change this, we'll go here, we'll add selected, we'll change that, and then we'll go ahead and apply. And again, that's just creating that connectivity. We'll save our edits again. And then we will validate our network here. Now, so what this validating network topology is doing is saying, okay, based on all those connectivity rules, is there anything invalid? Validate network topology is successful, so we're good there. So finally, let's select our interface unit and just perform an upstream trace. So under our interface unit, again, we've got these connection points and the ports within that. So I'm going to select that. And load that in as our trace start location. And now we'll do a strand upstream trace to our switch. And then we'll go ahead and run this. So this trace here now just confirms and validates that whole 10-click process to create that association, which can be done through a splicing tool, actually worked. That the strand has been connected to another strand, and now we can perform that upstream trace to see exactly where that strand terminates back at either a distribution hub or a point of presence, the originating source of that fiber. Now, the last thing that I'll highlight here is, again, the ability to pull up diagram views. So if we want to take these trace results and then pass them to like a single line diagram and get more of a kind of a diagram view, we also, again, have that capability. So not only the GIS and map view, but we can start to pull up more of a schematic view of equipment that we saw with like the patch panel and the rack, as well as more of a single line view schematic of a design. You know, again, this is two-way interactive, so we could select here and then propagate and apply this back to our map, which will again select the cable, the span network, the cable here, the span, and then those couple of poles that we had selected. Okay, so went through a little bit of a kind of a design scenario there, but we really built off that first desktop and walkout survey where we were leveraging an online hosted solution and consuming the data collected there within a desktop application that is also services enabled, and then using that to help do more of a detailed design where we had the enterprise solution where we're being able to manage our as-built down to the strand level and do this detailed engineering and look at connectivity and tracing of that final drop to that customer. So last demonstration for today is really just to kind of highlight more of the pervasive network access of ArcGIS. So a lot of these solutions here, again, leverage that comprehensive geospatial system and services architecture, and through a web portal allows users to access all the different solutions, maps, and apps that your organization is putting together. And so that's what we'll go and take a look at now for kind of the last couple of minutes here. So this is our example kind of web portal that manages all that geospatial content and maps and layers and our network services. And right away, we can see that based on my identity, it knows who I am and that I am logged in as myself. And based on that identity, we can get access to different network views. It tracks who last edited the network, and it enables access to different maps and apps like this lightweight communications viewer application. So through this web app, once again, I can see our as-built network. We've got all the kind of normal bells and whistles in terms of being able to search for an asset ID, zoom right to it. And again, we've got all of that rich attribute information that we can pull up on our assets and see again who created or when it was created, last updated. And based on my user login, I've also got access to this communications dashboard. And so this just summarizes that whole system of record, right? How many miles of cable plant do we have, or meters of cable plant do we have? How many points of presence are we managing on our network? And how many assets or structural assets do we have within our network? Another application here is this network operations dashboard. So this more provides us with that operational view of our as-built network, ties in real-time information, and can allow us to see any outages that may be going on. So if we run through a little scenario, let's say we've got a large storm event or a hurricane in this example rolling across our service area. So it's causing outages and service disruptions. It's creating our customers to call in complaining about no service or tweet about lack of internet or TV service. And responding to incidents like this typically requires multi-departmental collaboration. So for example, we've got customer service groups who need to have access to real-time and live outage maps that they can pull up and see the status of the network, as well as information like the average time to restoration for a particular area. You've got management and executive groups who need to be able to pull up kind of high-level reports and dashboards just in case local or national government officials call in saying, when is the network going to be restored? And then you've got the operations teams themselves who require web and mobile apps that provide them with the authoritative network information and the ability to assign work orders and tasks to field personnel, or to pull up surveys and mobile apps to actually go out and restore the network or do damage assessments. Now, since I'm here, a couple of other applications that I'll highlight. We'll just take a look at this kind of construction status dashboard. So I know there are a lot on the call that are part of that whole life cycle status of designing and building out the network. So again, through that services architecture and these maps and apps, you can put together these dashboards that would allow you to see the status of different areas of the network, see the actual fiber cables being built, and then have that ability to see kind of almost line by line, segment by segment, is splicing done, where are we in construction, are we in the planning phase, and then have that ability to select a particular area and just filter that information out from the rest, and then update all the charts and widgets. And this is all enabled through that system of engagement or that web portal that we are publishing our network and these maps into. So I've talked a lot, we've shown a lot. My last comment here is just going to highlight where you can start to get started with some of the solutions that we have seen here today. So we have a new solution site that is available that can allow you to easily deploy and download the solutions. So we'll send this link out after, but on here we can come to this site, learn more about the data management solutions, the online and the enterprise solutions. There's tools to optimize multi-site to site connections through backhaul optimization, or that B2B service qual that we saw in the desktop survey application. And the nice thing about these solutions is that there's a new way to easily deploy them right into that web portal. So launching up this solution site and filtering by telecom, we've got our online solution for the communications data management, and we can put in here the spatial reference for our, not our developer tools. We'll select that, I'll close this, and then we hit deploy. And so what this is doing is in the organization that I'm logged into, that web portal, it's standing up the maps, apps, layers, and the database behind the scenes that is empty that you can now start to pump your own data into and do your designs on top of. So very quick and easy to get these solutions deployed. So I won't spend the time here to wait for those maps and apps, but a lot of what we saw here today is deployed by deploying this solution. And so with that, I will be quiet. I enjoy and appreciate the time here today. Obviously, we'll all stay on to answer questions at the end, but I would like to turn it back over to my colleague, Mark, to really highlight some of the other users globally that have really deployed and leveraged a lot of these solutions. So go ahead, Mark.
All right. Yeah, Patrick, thanks a lot. Take a breather, sit down and take a rest. You had a lot to cover, and it's rather impressive. Maybe before we go too much further, Adam, wanted to ask you, do we want to see if anybody has any immediate quick questions that are just burning and touch on them here right now? Or?
We have two quick burning questions, if you don't mind, Patrick, and Mark as well. One question was, are the diagrams exports from CAD schematics or other software, or are they created in ArcGIS Pro?
Yeah, good question. So they are created in ArcGIS Pro. There is a network diagrams capability now that allows you to set up different schematic views and layouts of those. But if you've got existing CAD schematics, you can also import those in and then migrate that data into the GIS and visualize any type of CAD or Revit files even that you may have.
Perfect. I'll preface this next question, but just in an Irish context. But in Ireland, we essentially have three coordinate systems. We have Irish Grid, Irish Transverse Mercator, and then WGS84 Web Mercator. The question is, what advice can you give for working with data sets across multiple coordinate systems in ArcGIS Online?
Yeah, so there's a couple of kind of best practice options there. So ArcGIS Online is all Web Mercator based. So that's kind of the default. ArcGIS Online inherently will oh man, the word's slipping my mind. It'll reproject on the fly. So whatever coordinate system you have your data in, it'll reproject to Web Mercator. You can also go into a web map and actually define a coordinate system for a particular web map if you want to have that data in there.
Perfect. I think that's it for now. There's a few longer questions. We'll keep it at the end. Eamon, you were going to jump in?
Yeah, just on that last question about projections, I mean, this comes up all the time, regardless of whether it's the telecoms domain or some other domain. And, it's important that I suppose people understand that the different projection systems that are in use here have different capabilities in terms of their preservation of area and length measurements. And the only true measure is the ITM projection system. It's the only one that will give you accurate measurements of area or length. But that doesn't mean that you have to use it all the time. So particularly for the stuff Patrick was showing there in the walkouts and field use, I always say to people that, they're using a mobile phone with a GPS, so they should be using a WGS84 based projection like WGS84 actually, or Web Mercator. And then if they need to, they can back project that information into ITM. And just a word on Irish Grid, and the word is don't ever use it. That's 3 words, I think, because it's a legacy projection system, and it doesn't work well with mobile devices. And there's no accurate transformation between WGS84 and Irish Grid. There is between ITM and WGS84 because they both use the same datum.
Good job. I think that was it. Just the 2 questions, 2 quick questions. Anyways, Mark, if you want to.
Sure thing. Yeah, no, glad we could take a little bit of a pause there. Just kind of start running things down the home stretch here. At Esri, there's actually over 3,000 telecommunications companies around the world that are using ArcGIS technology, a lot like what Patrick showed you, and really in probably hundreds, if not thousands, of different ways. And these organizations range from some of the largest, most recognizable brands to the smallest, and even organizations that aren't really your typical telecom companies, but these are organizations that really rely on the communication networks or other types of systems because it's such a critical part of their overall business model. A couple of some specific examples that we always like to highlight and share, and we're always eager to hear about more. So if you have a great case study or an example of how you're leveraging your ArcGIS technology today in your organization and would like to share it, we'd love to hear from you. But at Reliance in India, GIS is used there extensively, and it's actually been able to capture over assets in the range of over 14 million unique features that cover the entire asset lifecycle, from the planning, construction, operation, and maintenance phases of that asset. And because the assets are managed in GIS today, now over 20,000 field workers actually have access to all of that information on a mobile device, and their daily work is assigned to them via GIS, where it's location based, proximity to where are my employees and where is the work that needs to be completed, and how can I do that the most efficiently way possible. And it's really allowed very large organizations like this to operate more efficiently, and thereby reducing their overall operating costs and improving overall customer satisfaction. At Comcast here in the United States, GIS has enabled their engineering and sales teams to really quickly assess if a prospective customer, a commercial customer, could access their services. And they can now complete the initial assessments in a matter of really minutes versus days or weeks. And this has led to increased collaboration amongst the various teams within Comcast, and has actually made them more competitive in the market, because they can provide a quote in a fairly short order of time, and the customer's not sitting there waiting for days and then maybe starting to feel like, well, these people aren't going to deliver, I'm going to go find somebody else. So it's been GIS has played a really pivotal role there in that particular department at Comcast. One of the significant investments, significant investment's actually been made into the network. Companies really need to be able to be prepared for just about anything. And that means planning for and responding to emergencies. And at AT&T, this is actually a very, very important matter for them. They actually model natural disaster scenarios with GIS, such as flooding, to determine which assets, which customers, and even which employees will be impacted by a flood event, and how to best respond to those situations when they do actually happen. At Etisalat in Dubai, a very interesting use case here, and I had a chance to spend a fair amount of time with them in 2019 learning about what they're doing with all of their treasure troves of data that they've collected over the years, and on just the performance of their network, what their customers are doing, how they're interacting with the network itself, and what they're doing is they're spatially analyzing all of their call records, really to derive new insights on customer behavior. This has created new information products within the telecom that they can then monetize and sell to other organizations as a service. And in particular, the city of Dubai, where there's any number of smart city initiatives that are going on, where having access to this kind of content is actually very important to them, and really helping them manage kind of the day-to-day operations of the city in Dubai. So just a fascinating situation for them to be in, and how they mine their data and do analysis against it, and then make it available for a fee for service to some of their customers. So what's going on at Esri? What's up with our technology? Where is it headed? That's probably a session that lasts all day long, and if not longer. Attending our international user conference that we've had for years, or spending time with our staff in Ireland talking about the technical direction is an interesting and worthwhile subject on its own, and it helps you plot your course and how you use the technology. But let's just say that we're very busy. We follow a process of continuous improvements of capabilities through incremental releases of our software. We don't wait a year or years for updates to the technology. It's something that we do in a lot more rapid or iterative cycle. What's unique at Esri is that we actually reinvest close to 30% of our annual revenue directly into research and development. That research and development goes into new products and increasing the capabilities of our current technology. And that 30% is well higher than the industry standard for software, as well as other geospatial providers. So many of our new capabilities that we're introducing are really driven by the requirements the business requirements within the telecom industry and users such as yourself. A couple of good examples to reference is what we're doing with imagery management and the capabilities to do feature extraction for asset collection, asset information collection, the work within 3D and augmented reality and BIM for facilities management and line of sight analysis are all really, really important capabilities and developments that we're working on. In the area of geospatial big data analytics and analytical tools, for better utilizing volumes of data that communication companies collect on their users, like I just referenced, something that we continue to work on and provide capabilities around. And then really more into the nuts and bolts of how ArcGIS is actually built. We're looking at doing things with containerization, Kubernetes, and microservices that really help, for better and more efficient deployment of ArcGIS for these really large enterprise GIS systems that are going on in some of the larger organizations. So finally, to wrap things up, here at Esri, we're really driven by the success of our users. We continue to be a strong and growing company. We're focused on advancing GIS technology that is engineering and science-based. So with that, your work is really important to us. We always appreciate the opportunity to work together to solve some of the biggest challenges within the business. We learn a lot from you that directly influences how the technology is built and the best practices that come out of that. So we want to really just thank you for the time today. I know we presented a lot to everyone on the call, but we look at this as kind of setting a foundation of understanding, but we would like to always hear from you and engage, your local Esri team. And if you have additional questions or you'd like to break down something that Patrick had showed in a demonstration and say, how do we really do that here within our organization? Can you help us? We would love to sit down and have those conversations with you and discuss those in greater detail. We're here to help. Just reach out and let us know. So with that, Patrick and I would like to wrap up our time. And again,